My name is Leigh Lunsford, and I'm in the Mathematics and Computer Science Department at Longwood University.
And I'm Phillip Poplin, also in the Math Department.
And today we're going to talk to you about how we've been using assessment to increase student success in our introductory statistics courses at Longwood University. Okay, so we have a problem at Longwood, and that problem is in our introductory stats course, and we have what is considered a low success rate. That is about 54% of our students, only 54%, complete the course with a grade of A, B, or C. We've been trying to understand what's going on with this, and so we've started to use assessment to try to improve the success rate. And we've used this in a two-pronged approach. First, we wanted to figure out where are our students mathematically, and we had an original study we did with that, which we'll tell you about. And once we did that, we wanted to use assessment to identify early and provide intervention for our weaker students, which we've done in a recent study, which we'll also tell you about. The important point we want to make here, too, is that we're not doing assessment just for the sake of doing assessment. We're doing assessment for a purpose, and that purpose is to improve our student success. Okay, so let me tell you just briefly about our Intro Stats course at Longwood. This is a standard elementary statistics course, and we cover the basic stats concepts, the descriptive stats, and some inferential stats, the t-tests, etc. This course, there's no prerequisite for the course, and it's a general education course. So any student can take it, and we have students from all across the campus. Historically, it's been mostly social science students, but now we're starting to see more students in the sciences taking it. Biology is about to make this a required course in their curriculum. Psychology has made it required. Our enrollment has actually increased in the course quite a bit over the last few years. Most of the professors in the course use a calculator. We use technology. We do all use the same textbook. We all have different teaching styles. But the main thing is the course is virtually algebra-free. We've tried to take as much complicated math out of it. And even with that, we still have our low success rate in the course. Okay, so Philip's going to tell you about an original study that we did, and I'll let him go with that.
Starting in fall of 2006, we started with our original study. We wanted to measure basic math skills. We used a test by Johnson and Coonan, and this was a 15-question quiz covering simple ratios, percents, slopes, things like this. And later in the spring of 2007, we added 5 additional questions to the test, and most of our analysis deals with the 20-question quiz that we gave. We were kind of interested in whether we had the same results that they did. So this data was collected over 2 years, and we are mainly starting in the spring of 2007 for 3 semesters of data. They include the 20-question quiz and what we're looking at today. And these problems, as I said earlier, are very basic math questions. This test is given on the first day of class, and we tell them that the quiz counts in some way, just so they'll have ownership of this. And we recorded at the end of the course whether the student succeeded in the class, and we consider a success either an A, B, or C in the course. I want to show a couple of the questions that we had just so you get a feel for the level of these basic math skills. Question 1, 645 adults out of 1,000 chosen adults said they hate math. What percent of those 1,000 adults hate math? And so this is a multiple choice question, and we have here the answer, 64.5%. And at the bottom I show that 73% of our Longwood University students answered this correctly. So you can see that's quite a few students who have missed a basic percents type question. One more of these. Approximately 5.3% of Americans are colorblind. Thus, the ratio of the number of colorblind Americans to the total number in the population would have what proportion? So again, here we're just asking, can you convert a percent into a decimal? And the answer is 0.053. And again, you see that just over half of the Longwood students answered this question correctly. So you see that there are a lot of students having trouble with these basic kind of percent questions.
So here are the results from that original study, and some are not so surprising. So first, students with low math skills were less likely to be successful in Math 171. And this graph here basically shows their score on the horizontal axis, their score on the 15-point test. In this study, we used a 15-point test, and their percent chance of being successful in intro stats. And so in this model, you can see that a typical student who scores a 10, I don't know if I could trace this out on here, which would be nice if I could, who scores a 10 on the 15-point question basic skills has about a 60% probability of success in the course. Okay, so basically our basic skills test that we were using is a fair predictor of success, of student success, which was also a similar result that Johnson and Coonan got as well. Some other things that we discovered that were very interesting as well is that we had a professor effect. What this means that is for a given test score, a student may be more likely to succeed with one professor than another. In other words, students coming with the same basic skills have a better chance of success depending on their professor. So here you see those success curves, like the last one we just saw, but now by professor. And there's sort of a middle professor, and then you see a spread, professors that would be easier, those are the top curves, and professors that would be harder at the same test score level on the horizontal level there. That was the professor effect, which we thought was not good, given that this is a general education course, and we feel like that should be a course that's consistent across sections. Oh, there it is. Attendance at the Learning Center, which we measured as well in our study, it was not a significant predictor of success. However, one of the problems was that very few of our students were actually attending the free tutoring offered by the Learning Center. So this original study we did, again, as Phillip said, started back in 2006. We collected our data and we published that in the Journal of Statistics Education back in 2011, our results. Okay, and so now we have our new study. Oops, well, I'm sorry, Phillip's going to talk about lessons learned next.
So after this original study was done and we compiled our results, we really noticed some things, particularly the first one, teaching even a computationally light stats course. Basic math skills are important, and these skills are needed to understand simple statistical concepts, in particular ratios and proportions. And we noticed that a lot of our students just did not have the skills that we were expecting them to have when they came in. And students can't work and reason with ratios. They're probably going to have a difficult time in our Math 171 statistics course. So how does this impact our teaching? Well, we're much more aware of the math level of our students. I expected them to know a lot more basic math than they turned out they really did. So now we know this, and we can review basic mathematical concepts before we introduce some ideas that really require those. And so we use this basic math skills test to identify early students that may have trouble in this course. And after our first study, we started trying to get them to go to the Learning Center for extra help. Now we have other ways of doing assessment, in particular our online homework systems that we use now to make sure the students are doing a lot more work than they used to. And now we are aware of this professor effect that we had. We have tried to come up with ways of reducing that professor effect. We've improved our common exam questions that we give across all of the sections of the math course. And of course we are sensitive to some of the other things, such as academic freedom for making your own exams out, whether you want to use calculators or not. Some professors, at least in the first day, did not use calculators. Most of us now use, actually all of us use calculators now.
Okay, so this is back to the idea of using assessment with a purpose. So we did this first study, and so we saw that our students were weak with their basic math skills. So we decided to have another study. And in between that first study and second study, we started requiring students to attend the tutoring. So our new study is based on this. So our purpose in our new study is we're going to use our assessment to identify students who may not be successful and require what we call early intervention. So now we're using that 20-point basic skills quiz that we modified the 15-point one from Coonan and Johnson. And it's a departmental policy now that any student who scores 50% or lower on that 20-point quiz is required to have 6 hours of tutoring in the Learning Center during the first half of the course. And if they don't do this, they automatically fail the course. So they have a very good incentive to get that tutoring. And let me just say, this may come across as sounding negative, but we do tell the students, look, we've done the research. We know that if you're scoring in this range, you're less likely to be successful. We are trying to do everything in our power to help you be successful. So this is not a punishment. This is here to help you. So now we're taking our assessment instrument and identifying our students who may need this help. And just some general information compared to our last study and the one we're in now. Our original study was actually 4 semesters, but since we're looking at our 20-point quiz, we have 3 semesters, which was the spring of 2007 to the spring of 2008. And we have 5 professors in that study and 500 students. Our new study is also over 3 semesters. Now we have 7 professors, 3 from the original study, and look at the students now, 814. So you can see that our enrollment in Math 171 is going up because more people are starting to require it, which is a good thing, I think. All right, so Philip's going to tell you about our results.
So to compare our new study and the previous study, we see that in the previous study, we had about 53.8% of the students were successful in the course. After this new study has been done, we see that the success rate is 64.7%. So indeed we have a 10.9% increase in the proportion of students that are successful. This is statistically significant. And we might just point out here that the percent of students who scored 50% or below was not statistically significant. It was about 24% of our students that score 50% or below in both of these studies.
And I would just like to note that number. 24% of our students cannot get 50% or more points on this, or above 50%, I should say, on this basic skills quiz, which is kind of a shocking thing.
Yes. So some reasons for this improvement, this percent of success. Now the professors, of course, are much more aware of the level of our students, so we can spend the time when we need it at the beginning to explain ratios and proportions a little bit more. Professors share and collaborate on a lot of our materials now. We have slides that are used by most of the people in the department. We share tests and a lot of our assessments between professors. And we have gone back and improved our general education Common Core assessment. The questions are more in line with what we're actually teaching. We know this up front, and we can make sure all the students are ready for those. So the question, how did our required intervention potentially impact these results?
Okay, so what we decided to do was look at, of course, those students who we required to have the intervention and look at their success from the previous study to the new study, and the students who were not required the tutoring. And so if you look at this by the students who score 50% or lower, i.e. about 24% of the students in both studies, we see a pretty dramatic increase in the percent of students who are successful. That's a 15.8% increase, and that is significant. However, I do want to note that the percent who are successful in the new study was still only 54.3%. So these students coming in with these very weak math skills really are not very likely to succeed, but we have, through this effort, we believe, made a dent in making that a higher success rate. If you look at the students who come in who score 50% or higher, did I get that? There it goes. over 50%, we saw that their success rate also increased. So remember, the overall success rate increased by, what percent was that? About 11%?
Mm-hmm.
Yeah, and so this group that scored over 50%, had an increase of about 9.4%, okay? And so you see a big jump there from 58%, 59% in the first study being successful to about 68%. So I'll say again, our overall success rate is 68%, which is still probably not high enough, but given the mathematical level of our students, I think we're getting somewhere at least. So we see an increase in success of about 16% for the students who scored less than 50% of the basic skills, and 9.4% for the students who scored over 50%. So the question is there a difference in those 2%? I mean, is that really significant? And the answer is yes. So we used a certain statistical test, and basically that is significant. So we saw an overall increase, but the increase for the students who scored less than 50%, for the students who were getting the required intervention, was significantly higher than the increase for this overall, basically. So, of course, we can't say association means causation, but we do think that this intervention may be helping those students.
Another question we would like to think about is our professor effect. The professor effect in the first study, which we talked about earlier, you see we had 5 professors working on this, and 1 professor there in the middle, and the other 4 professors are either much higher or much lower. And in our new study, this is 7 professors now. There is 1 professor that's pretty high and 1 professor that is much lower, and there's 5 different bands right there in the middle. So most of the professors are right there together. And it turns out that none of these are particularly statistically significant, even though there is a little bit of spread there. You see the real big clumping in the middle for most of the professors, though. So that also seems like a good result. I might just mention a little bit about administering the test, just so we'll know there is a little work required, but not very much for the professor. They're going to administer the test on the first day. We now have this set up on scannable forms, and so we can just have those all scanned into the computer for us. And then, of course, we'll verify at the halfway point that they've all had their 6 hours of tutoring. Of course, we normally make a few announcements throughout, but those records are kept actually by the Learning Center staff, so we don't really have to deal with that on a day-to-day basis.
Okay, that's our story of how we're using assessment to try to improve our student success in Math 171. And so I guess Phillip and I will discuss these last few things here about how could we make this better. So one of the things we've talked about is having the tutoring, the free tutoring in the Learning Center, be more targeted towards specific topics. Right now, I think basically the students go in and just ask for help on homework. And we have tried a few things here and there, but nothing real systematic. So that is a potential thing we could do.
Mm-hmm. And we're actually going to start that this spring, is to have a more targeted Learning Center tutoring session for them. So hopefully we'll see how that works out.
Right. And then the other thing is that seeing that big, the significant percent increase in success for the students who score below 50% because of the required, well, we think it may be because of the required tutoring, we're wondering, should we require tutoring for all the students? And so should they have some required amount of tutoring over the course of the semester? We haven't really discussed how we would do that, but we've thought about that.
Mm-hmm. One of the problems that we do have right now is faculty teach material in different orders, and slightly different concepts are taught by certain professors. So it would be nice for the faculty to teach the same material in the same order. We're kind of still discussing that, in particular how to get the targeted Learning Center to be able to tutor different students who are at different points in the book, in the course. Of course, one of the things we have been discussing is to talk about more of a departmental final. And at this point, we have 8 common questions that all the professors use on their final. A lot of us use a lot of questions from one final to the other. So there is this possibility maybe we could have about 3/4 of the final exam common questions sometime.
Right. Not everyone in the department is too excited about that idea of a common final. So if we could do that in a way that still preserves academic freedom for the professors, so that's just a thought, a possible improvement. So I guess the concluding thing here is, and again, the main point that we made at the beginning of this is that we're doing assessment here not just for the sake of doing assessment. We are doing assessment with a purpose, and our purpose is to help our students succeed. And we think the assessment tools we have been using are doing that essentially. They aren't perfect, but we're learning lessons from it, and that's the important thing. Any other comments, Phillip?
I think that's it.
Think that's it? Well, we thank y'all for listening to us. If anybody does, we hope you do. And happy 2013.
Thank you.
Thank you.